So friends, let's start with a new topic, electrostatic. So very first thing we need to understand in the electrostatics is the Coulomb's law. The Coulomb's law gives us, it gives us force of interaction between two point charges. Okay, it gives us the force of interaction between two point charges. So to understand the Coulomb's law, first we need to understand the point charge. What is a point charge? Okay, let's consider two charges Q1 and Q2 as shown in the figure. Let's say the dimension of this object, the first, is say A, and the dimension of this second object is say B. Okay, and let's assume the distance between them is R. Okay, so if R is very big with respect to A and B both, okay, that means dimension of the charged objects is very small with respect to the distance between them, then we can treat both these charges as point charge. Okay, so you see whether I can treat these two objects Q1 and Q2 as point charge or not, it depends upon the distance between them and their dimensions. Okay, it does not depends upon Q1 and Q2, that means the magnitude of charge. Magnitude of charge can be any, okay, it may be any amount, it may be small or large, hardly matters. Okay, so whether we can treat two objects as a point charge or not, that depends entirely all upon the distance between them. If the distance between them is very large with respect to the dimensions, then we can treat both the charges, both the objects as point charge. Now we can understand, once we understood the point charge, now we can understand the Coulomb's law. The Coulomb's law says that the force of interaction between two point charges, is directly proportional to product of magnitude of two charges and inversely proportional to square of distance between them, Okay, so if Q1 and Q2 are 2 point charges separated by some distance r, then the force of interaction is proportional to Q1 Q2 by R square, and therefore force of interaction can be written as K Q1 Q2 by R square, where K is the constant of proportionality. Okay. Now this constant of proportionality depends upon the medium. It depends upon the medium between the medium in which these two charges are placed. Okay, medium in which these two charges are placed. Okay. The value of this constant K is 1 upon 4 pi epsilon. Okay. In the SI system, the value of this constant K, in the SI system is 1 upon 4 pi epsilon Q1 Q2 by R square, where epsilon is the permittivity of the medium. Epsilon is the permittivity of the medium. Okay. Now we can define, okay, relative permittivity. Okay. Now suppose before we define the relative permittivity, let's say the charges are placed in vacuum. Let's say these charges are placed in vacuum. If these charges are placed in vacuum, then the force will be given by 1 upon 4 pi permittivity of vacuum, which is represented as epsilon naught. Okay. So the force is 1 upon 4 pi epsilon naught Q1 Q2 by R square, provided the charges are placed in vacuum. Okay. If the charges are placed in any other medium, then the force will be given by 4 pi epsilon of that medium into Q1 Q2 by R square. Okay. Now we may define relative permittivity. Okay. Epsilon of a medium upon epsilon, that is the permittivity of the free space or vacuum, permittivity of the medium upon permittivity of the free space is called as relative permittivity or dielectric constant K. So permittivity of any medium can be written as K times epsilon naught, where this K is dielectric constant. This K is dielectric constant. This K has nothing to do. This K has nothing to do with that constant of proportionality we have taken. Okay. So we can say that the force of interaction between the two charges is 1 upon 4 pi epsilon into Q1 Q2 by R square, where epsilon is the permittivity of the medium in which these two charges are placed, which can also be written as permittivity of the medium can also be written as epsilon naught times K, where K is the dielectric constant. K is the dielectric constant. Okay. So, a final conclusion. The electrostatic force of interaction between two point charges is given by 1 upon 4 pi epsilon naught K Q1 Q2 by R square. Okay, where K is the dielectric constant of the medium in which the charges are placed. Okay. Further, the value of 1 by 4 pi epsilon naught is 9 into 10 raised to 9 in the SI system. Okay, in the SI system, the value of this constant is 1 upon 4 pi. The value of 1 by 4 pi epsilon naught is 9 into 10 raised to 9. Okay. So from here onwards, we will talk in the next meeting.